Welcome everyone to the Securing Your MongoDB Deployment webinar. Thanks for filling out the pre-webinar survey so diligently. My name is Andreas Nielsen. I'm the lead security engineer at MongoDB. And titles ignored, what that means is that I'm essentially responsible for the group that builds the security features in the database. So I work on the kernel team, not on the cloud services team. So what we're going to talk about today is security in MongoDB and security around databases in general. What constitutes a secure system? There's a lot of talk about security, obviously, in the world today, but what does it actually mean in the context of an application deployment, and how can you make sure that you use the functionality that exists in MongoDB as good as possible, but also what are some sort of decisions. I want to try to explain some of the decisions we made and some of the decisions we sort of enable you to make around security. So let's get started. During the webinar, it's possible to ask questions. If they fit into the flow, I might answer them during the presentation. Otherwise, we'll take them at the end. So going back a couple of thousand years, from my point of view, security is very much like a battle. You battle some kind of enemy, and I like this quote. It's from a Chinese philosopher and war strategist. If you know the enemy and know yourself, you need not fear the result of 100 battles. If you know yourself but not the enemy, for every victory gained, you will also suffer a defeat. If you know neither the enemy nor yourself, you will succumb in every battle. So what does that mean in the context of database security, or in the context of IT security in general? Well, for me, it means that if you know, if you don't know the tools of the enemy, if you don't know who is trying to attack your system and with what means, what they're interested in, you're going to be in the dark. And if you don't know what tools are available to you to protect against it and take proactive measures, you're also going to run into defeat. But if you know both of these things, you stand a good chance of actually building secure systems and sort of protecting your assets and not just not getting into troubles, but also building a stable environment. I'm very much in favor of the same philosophy that Linus Torvalds has around security. Security is not just a specific field that should be treated specifically. Any security bug should be treated like any bug. It's a stability bug. It's just something that that should be thought about in the same context as everything else we're building. So the four main topics I'm going to talk about today, or the sort of four areas, is securing a database in general. Where does the database fit into a larger system, a larger deployment? Then I'm going to go into three specific parts of MongoDB. Access control, how do we implement access control? Data protection, what are some alternatives? Auditing, how do you audit your system? How do you create a reliable audit trail? And how do you use that? And I'll also give a couple of sort of general tips for what I see clients or users of MongoDB most often making mistakes, or what the most common mistakes are, and sort of how to avoid them. So if we start with the first portion here, securing a database. So I'm sorry for the poor resolution of this picture. Essentially, ignoring everything here except the fact that it's messy, somewhere in the middle of this large deployment and large sort of set of data sources sits a MongoDB database. We're getting data, we're getting input, we're getting data from a bunch of different systems. You can think about this as any type of larger deployment. Um, this is some schematic picture of a larger system as used today. You have some ingestion service, you have some business intelligence reporting, and how do you make sure that all of this data is secure? And what can you do from the database side? So my main advice, or my main coming from coming from years as being a security architect in the financial sector, is that a lot of times security is not something we think about early on when building a system. We design our system, we implement it, we test our system, and then when we're supposed to deploy it, we go and ask the security guys, is there something we should think about here, or did we screw up? Like, this is not a good strategy, especially not when working with databases. So in my mind, security should be built in already when gathering requirements. And when so this could be the requirements for your database deployment or your design of your database deployment, but as much your design of your actual application. What are the requirements? What is the sensitive data you're trying to protect here? What are your legal requirements, compliance requirements? Who is do some basic threat modeling? Who is going to try to attack this application? Who is interested in it? It's very easy to become dogmatic in terms of security and start looking at actual measures instead of looking at which measures apply for which situations and systems. Anyway, main advice, do not wait until the deployment phase to think about security, especially with the database, because if you don't think about it until you're deploying, you might make decisions with your database or your database setup that will make it very, very hard for you to improve, well, to ever get to a safe system. So this is also sort of a kludgy picture, and it's intentionally kludgy because we have complex environments. And the main thing I want to show with this picture is that it's important to consider your database deployment, especially your application deployment in general, from the point of view of what are from a network point of view and access point of view, who can get to my database, who can get to the actual ports of that are open, who needs to get to it, how much can I lock it down, is it only my application, is it administrators, is it business intelligence data, have I segmented my networks properly. It's actually not uncommon at all for us to see people putting, users putting up MongoDB databases or other databases directly online on the internet. There is no good reason to ever do that, although we see it all the time, especially, it's even worse if you do it without authentication. So it's important before you do anything to map up where should my database be and try to minimize the access the unnecessary access to it. Try to identify who should have access to my database and make sure that only those interfaces and only those entities do have access to it. So that was sort of setting the context for what we're talking about. If we move on to the next part that I want to talk about, it is access control. So what do I mean with access control here? Well, I mean, once you've set up your once you've placed your database on some known network location, the next step is to control who can access it. Let's say you put your database in a secure vault with a single dedicated IPsec VPN to it from a single computer. Then you might not have to do anything with your database. You can just leave it as is. However, if that's not typically the case, you have multiple entities accessing your database, then you have to think about access control. So you might have someone that needs certain type of access and other entities like administrators that needs high privilege access. And by default, MongoDB comes with no access control enabled at all. So this is a step we recommend everyone to take to enable access control. And the same way I showed the picture of the general deployment scenario, access control is something to think about all along your deployment, already from the design and requirements gathering phase. So if we think about, MongoDB configuration, I'm sorry for the spelling mistake here. If you think about what does authentication and authorization mean? So those are the two components, typical components of access control. From an authentication point of view, we want to know, well, who are the different types of users that you can have in a deployment. So you have application users, typically you have administrators, backup jobs, monitoring agents, and all of these entities or all of these users, if you want, have different privilege requirements, and those are requirements that need to be mapped up by the system administrator or by the system designer before you go ahead and enable access control. From an authorization point of view, we have a number of different operations you can perform, CRUD operations. You have different sets of commands to configure the database, manage sharding, manage users, and I'll go into some level of detail about the different methods for authentication and the different methods for authorization. But suffice to say at this point that we have a role-based access control model in MongoDB. So typically what you end up having is that you map your user types to one or several roles that have a certain set of permissions in the database. For the actual authentication piece, we have some different options. So here I'd like to also present the philosophy that we've had or we have in general when building security features in MongoDB. So we're trying to simultaneously make the system easy to use, easy to get started with, but at the same time possible to integrate into complex enterprise environments. These are sometimes conflicting goals and sometimes similar goals, or sometimes they work together. Anyway, for the authentication piece specifically, there are two separate tracks here. We have a built-in password challenge response protocol. We're using Scram SHA-1, the salted challenge response authentication mechanism protocol. It's also possible to use X509 certificates if you have SSL enabled on the server, for authentication from clients to the server and in between the servers, between the MongoDB servers. Or it's possible to integrate with an existing authentication infrastructure like an LDAP directory or Kerberos. Kerberos is the method we recommend ideally. if if you have a Kerberos environment already present. The advantage of using LDAP or Kerberos is obvious. Ideally, we at MongoDB, we do not want to be, the MongoDB server would ideally not want to be the um, manage your users at all, because what's going to end up happening if you have multiple user directories, you have a set of users in MongoDB, you have a set of Kerberos users, you have a set of other types of users, and you have all sorts of local systems have their um, own set of users. When a user in the system changes roles or leaves the company, or when a new user comes in, you're going to have to coordinate all of those systems, so the identity lifecycle management becomes very complicated, which is why it's always a better option to use a central user repository if possible. So I have two questions here that you can take right away. By default, there is no user administrator created for MongoDB. This is a conscious choice that we have made. The first administrator is created by the end user as part of enabling authentication. And by LDAP, yes, it's possible to, we have interrupt tested with, it's possible to connect to any LDAP directory. We have interrupt tested with Active Directory and Open LDAP. Ideally, it should work with any LDAP server that works according to the specification. So the process of enabling access control is, first of all, as I mentioned, you determine which types of users exist in the system. As I mentioned, they might be different sets of applications, administrators, monitoring agents, and so on and so forth. And then you match those users to MongoDB roles. And it's also possible to create customized roles. So right now, there is a, switch to the next slide quickly. There's a number of built-in roles in the system. You have read, read-write, DB admin, cluster admin, root role, etc. There's a number of them. You can find them in the documentation. But there's also a set of around 80, 90 specific privileges that it's possible to use to create customized roles. You can customize and create a new role based on existing roles and or specific privileges. To deploy access control, you start or restart MongoDB with access control enabled. And that's the --off flag. I'm not going to go into a lot of details on how to actually configure the system. That's sort of well documented. But if you do not start MongoDB with --off, or then you will simply not have access control enabled, and anyone connecting to the server have full privileges. The next step is create the desired users, obviously. So I already covered this one. An important piece to be aware of here is the difference between external and internal authentication, or you can call it different things. But if we have this schematic view is of a sharded system, so the query routers are what we would call MongoS, and then we have a bunch of shards, so primaries and secondaries, and application, and some kind of driver. You could also imagine having the shell here. So what we call what we typically think about as authentication is from the shell or from the driver to the Mongo system here, or Mongo server. But it's also important, we also have a piece where all the Mongo servers are authenticating to each other and prove that they are part of the cluster, since they are using the same command API that the that the clients are using from on the server. And that it's possible to use a shared key file solution for cluster authentication or X509 certificates. And the way you configure that is also documented, but we choose to implement the X509 certificate solution so that there are certain properties that are required from an X509 certificate to be considered a part of the cluster. And if those properties are met, you're considered a part of the cluster. What that means is that you can simply add a node to the cluster, and it will be possible to talk to it will be able to talk to everyone else without having that node being registered in all the user databases of the user collections on the other servers. So here are some things that I get a lot of questions on, and that are somewhat, wouldn't say unclear, but somewhat somewhat hard to deduce from the documentation. So if we talk about a sharded system first, the users of a sharded system lives on the config servers. So the query routers or the MongoS, they do not have their own data store or database. Instead, they use the config servers, and the config servers for the authentication piece, and the config servers have the actual users. It's important to know that up to this point, it's also possible to have local or shard or replica set users. And for maintenance purposes, this might be a good idea in certain circumstances. In 2.4, which is still widely used, but becoming less and less used, the users are located in the actual database that they belong to, and in a slightly different format than in users in 2.6 and onwards, where the users all reside in the admin database, and hence all the users. So there's a specific difference, sort of intricacy here. Since there's the local database, that database is not replicated, and you could have local users that were not being replicated. Into 6 and onwards, all users are always replicated. And so all primaries and secondaries, all replicas within a replica set, has the exact same set of permissions. An interesting addition to the access control system is something that came with 2.6, is something called field level redaction, or it's based on a new aggregation operator called redact. What you can use that for is to, among other things, it's pretty powerful actually. You essentially can use it to conditionally filter certain user documents. You can do certain types of user document level access control. You can implement certain types of content filtering, create egress filters for your database, and redact generally sensitive information. So how does this work? Conceptually, you have your application, you have your database, and then you have some form of middleware or implement a layer, a protection layer that has a redaction phase using the $redact operator. So conceptually, let's say we want to prevent this application from ever, or we want to make sure that only certain users of an application are able to extract social security numbers from the database, then we can implement that protection that we flag those specific fields in the database, and the redact phase that is also, so side note or important note here is that this actual redaction layer has to be implemented on a case-by-case basis as part of an application deployment. It is not, even though the tools to do it are delivered with MongoDB, the actual implementation has to happen on a case-to-case, case-by-case basis. Those rules are enforced by MongoDB. And the enterprise user directory here is not specifically relevant for this picture, but it sort of gives a general ID. Most of the time you want to use these enterprise user directory entities as part of your field level redaction solution. As I mentioned before, this is well documented, and if you're curious to hear more about it, talking to me or talking to one of our solution architects afterwards is probably the best route forward. Going over to the third part of this presentation. I'm going to talk about data protection in general. So both data protection in transit and data protection at rest. So there are lots of ways to, this is a very complex area anyway, and there are lots of ways to protect your data. And I would like to point out, the same way I pointed out for previously, that the most important thing to figure out here is what type of data do you have, what type of protection requirements do you have in your data, and in which environment is your data residing in, where does your database sit, where do your applications sit, and who are the adversaries that will be interested in this data, and what are the compliance requirements. And those are things you can definitely think about during very early stages of your deployment. Sorry if I repeat this picture, but I cannot enough stress how many security issues would be avoided or be made much more cheap to fix or less impactful if these considerations were happening early on rather than late in the game. So if you look at some overall picture of where data protection would happen in MongoDB specifically, and I would say that this is a general picture for any database or storage system. You have a bunch of applications here, and they connect to the database. All of those connections can be protected with SSL or TLS, I would say. With the recent advent of SSL vulnerabilities, actually MongoDB does not support SSL at all anymore. Even though it's general word, we have disabled SSL v3, so it's only possible to use TLS. But I use SSL for sort of easier to understand what we're talking about. So transport encryption can be enabled and should be enabled. There's no good reason I can come up with except slight performance impact potentially that makes that for why you would not enable SSL. The thing I can say about performance there quickly is that typically the types of queries you make to a database, depends a little on your workload, but most cases, the SSL encryption and decryption would not be the sort of limiting factor, but rather the actual database queries. If we look at the other side of the story, and also all the communication between the nodes are protected with SSL. Not by default, it has to be enabled. In terms of the actual storage layer, there are some different options. You could encrypt the data files. You can encrypt the transparently. I'll go into detail about that in a couple of slides. So just to go over the SSL portion first, like I mentioned, it's possible to protect client-to-server and server-to-server communications with SSL. MongoDB supports commercially and internally issued X509 certificates, so that you can go and buy them from a large vendor of large certificate authority, or issue them using an internal certificate authority, or creating your own CA by using OpenSSL, for instance. It's possible to run the server in FIPS 140-2 mode so then the crypto and SSL connections are happening with OpenSSL in FIPS mode. If you do not know what FIPS 140-2 is, then feel free to ignore that. If you do know what it is, it's probably because you might have compliance requirements to function in sort of to use FIPS 140-2 crypto, and yes, we do support that. We support mixed SSL and non-SSL clusters from 2.6. What that means is, for instance, that it's possible to do rolling upgrades from non-SSL system to an SSL system. It's also possible to have end clients that aren't yet SSL enabled connect, if so specified, to connect to your server. I would like to point out two main things that I see misunderstandings around. So SSL is a fairly, or certificates in general, not SSL, it's a little tricky to get right. There's a sort of certain amount of background knowledge you need to have. The two things I'd like to point out here is that if you are using self-signed certificates that were generated by using OpenSSL, for instance, there is no trust in those certificates in between the nodes. You will get encryption for sure, but since there is no in an SSL setup, the trust is provided by out of bounds by trusting a certificate authority. So if there's a self-signed certificate, that by definition is the certificate authority. So there is no inherent way that the nodes trust each other. And the same way, if you do not provide so when you start a MongoDB node with SSL, there's an option to provide a CA file or CA certificate to base trust upon. So all certificates signed by that CA are automatically trusted and other certificates are not. If you do not provide a CA file, you will get a warning, but the server will start. But it's equivalent to trusting any certificate that's provided. For X509 and SSL authentication, this isn't X509 authentication is not going to work if you do not provide a CA file, simply because there is no trust. But however, SSL connections they're still possible. Going over to the so now I'm I'm showing the same picture that we looked at a little while ago. We're not going to dwell on this one. The only thing I wanted to point out is that all the connections in between the clients and the servers and the servers are possible to protect, and it's possible to authenticate the connections, all these connections, using X509 certificates. X509, for those of you who do not know that, is simply a standard for digital certificates, or a format for digital certificates, and they sort of so it's client certificate authentication. If we talk about encryption at rest, there are some different alternatives. It's possible to encrypt data client side, obviously, in the application. This is, in many cases, the best solution. There are independent solutions for file and OS level encryption of the data files, or we partner with one company for transparent data file encryption. For the next release, 3.2, we'll see which release is going to happen. We're looking at adding an encrypted storage engine, but we will see. So I have a question here. How much performance impact does transport encryption have? Sorry, that was on the SSL portion. It all depends on your workloads and what type of connections you're making. So it's impossible to sorry for jumping topics here. It's impossible to say that in the general case. But like I said, most workloads are more query intensive than network intensive. So in a large initial sync case, it would have a little bit of impact. But I don't have any actual numbers right here. So the question here, I got another question. Can I repeat the encryption options that exist in 2.6 and 3.0 versions of MongoDB? So the encryption options in 2.6 and 3.0 versions of MongoDB are the same. We are looking to potentially adding support for an encrypted storage engine, although the current solutions encrypting data client side or using a partner or independent solution for file level encryption satisfies, I would say it satisfies 100% of the use cases, although for the advantage of having it built in is that you do not need a partner solution. But there are some other disadvantages with that. But it's a long discussion that we could have offline this webinar. So the fourth piece that I wanted to talk about that is and as important, I would say, as many of the other portions, not just for compliance reasons, but for actual monitoring of the system, for actual investigations and forensics of incidents, is auditing. So my philosophy, going back to how I see security work in general, is that breaches are in one way or another always going to happen, or administrators are going to internal administrators are going to misuse their accounts, passwords will be lost or stolen, credentials will be stolen. So it's very important to actually be able to see what kind of access control decisions have the system made, and what has actually, in addition to just viewing log files that might be, first of all, not complete, and second of all, not focused on sort of security portions of the system. So what is an audit log? It's essentially security events. They can be written, so it's security events. We're logging security events. They could be written to the console, syslog, or to a file in JSON or BSON format. By default, all security relevant events are written to the audit log when it's enabled. The events include authentication failures, some commands, and access control decisions. Side note, access control is not required to be enabled to do auditing, although I would recommend it. There are less there are less uses for it, since if you do not have access control enabled, you will not be able to audit who did what with the system. So I got a couple of questions here, but they're a little on different topics, so I'll bring them up during the Q&A session. So talking more about the audit log, we can filter. So you might not want all of these. You might not want all of the all of the audit events. It depends. You might want to just audit a certain set of users, a certain type frame, certain types of actions, or certain IP addresses or ranges. So it's possible to filter that. It's an important thing to note here is that events have in the audit log have a total order per connection. They do not have a total order per system. We do provide. So the question here is auditing a synchronous or asynchronous logging event. So the way it works is that we make audit guarantees for all writes or for any change in configuration of the database. So the way that happens is that audit events are written to disk before they are written to the journal. This is an important piece of being compliant with audit logs. So write will never be completed before it has been audited. You could imagine cases where a write enters the audit log, but subsequently fails for other reasons. It's a bit of a black swan event, but it's possible, but it's not possible that a write completes but is not audited. So I got a question here. If we have some standard filter strings that are being used, we have a couple of examples. I would recommend contacting, I'm not sure how much is in the documentation. I would recommend consulting the documentation and contacting support or the solution architect team, or just write to me and I will forward you to the right sort of entity to talk about it. So that was auditing. Let's see, we have a couple of minutes. We have 15 minutes to go here. We're gonna be good on time. So some final tips, and actually, if everyone listening in here if this is the only takeaway, these couple of tips that I'm going to give you now, this is the only takeaway you get from this webinar, I'm going to be very happy that I did it. So here it goes. Some tips along the way. 1, do not directly expose database servers to the internet. This is not doing anything. This is not MongoDB specific. This is simply a matter of protecting your interfaces. And so if you do not need to expose a certain service to a certain set of users or a certain network, just don't. Limit your exposure as much as possible. This can be done in several ways. Network segmentation and firewalling being the most common one. Design and configure access control. So, like I mentioned, if you fire up a MongoDB instance and you have not configured access control, there will be no access control configured. Number 3, enable SSL, transport encryption. Number 4, provide SSL CA files to the client and server as a trust base. If there are no certificate authority files, there is no SSL trust. There is only encryption. 5, disable, this is related to number 1, but this is more on the MongoDB side actually. Disable any unnecessary interfaces and any unnecessary functionality that you might not need. There is in our security checklist, there's a number of, it's online accessible, there's a number of hardening steps that can be taken, and a number of recommendations for things that should not be enabled unless you are aware of the decision you're making and you absolutely need those features. Number 6 here, we see pretty often problems with. So database files in themselves are sensitive and should not be, well, they should be protected adequately, and the account privileges for the account that runs the MongoDB, but there are also other configuration files in the system that should be protected that are used by the Mongo server. These are general principles that also minimize the account privilege of any daemon that runs on your system, including the MongoDB servers. Also, use a dedicated account that is not root, and do not use it for other things. So these were the basic things I wanted to go through today. I want to talk about a little bit about our different versions of MongoDB. So there's the open source community version. Then there is the enterprise version that includes a bunch of the different things that are more targeted towards enterprise environments that I mentioned. Like Kerberos, LDAP, X509 authentication, auditing, SNMP support. There's a list of different features that are only available in the Enterprise Edition. Then we have disaster recovery. We have a included in this package is something called Ops Manager it's an administration tool that can be used to automatically upgrade, downgrade your clusters, do disaster recovery solutions, and monitor your system. We have, there's an SLA time, and we also certify the MongoDB binaries for the most common platforms. So depending on your use case, this might or might not apply, and depending on going over the MongoDB Enterprise Advanced, there's the MongoDB Ops Manager that I mentioned. So MongoDB Ops Manager is the on-premise version of our monitoring solution, together with a bunch of new administration features to make administering your MongoDB cluster hopefully less of a pain and more of a pleasure, but that's the goal anyway. Then, as I mentioned, there's a certain set of security features that are only available in the enterprise version. On-demand training, what that means is that you log on to the website, to our education, program that is online, and the users of the organization, the users in your organization can take the trainings anytime. Otherwise, some of the trainings are given at certain times. And then there's the SLA, obviously, standard support, and a commercial license. And there's a pricing for completeness. So summarizing, so we have 10 minutes to go over the questions. What did we go over? Securing a database in general. What is the context? Why do you do it? How to think about it? Access control. How do you enable it? Why would you enable it? Data protection in transit and at rest. And then I talked about auditing. One important thing that I forgot to mention about auditing to think about is, well, two important things actually. One of them, in order for audit logs to make sense, all the servers have to be time synchronized, because otherwise it's hard to, so they should be contacting the same, or they should all be connected to an NTP server. So there's other reasons for that. If you have clock skew in a MongoDB cluster, you might get problems with your sharding setup. But so that's an important piece. The other important piece is that audit logs, the idea is that the administrators who are being audited partly should not be able to alter the audit logs afterwards. So shuffle the audit logs away to some third-party place or to some location where the people who are being audited, or the end users who are being audited, cannot edit them. Sort of best practice regarding logs and audit logs specifically. I'd like to finish off with another quote by Sun Tzu. All men can see these tactics whereby I conquer, but what none can see is the strategy out of which victory is evolved. So security is a difficult discipline. We all see when things go down and when things fail, but we don't see all the small details and all the small decisions that were involved with making it successful. That's basically the idea. Security is an interesting topic in the sense that failures are very visible and successes are not so visible. Even so, it's the world we all have to work with. Okay. Before questions, next steps. There's the MongoDB security manual. There's a MongoDB security white paper. In the security manual, there's a bunch of nice things like a security checklist summarizing sort of, or bullet pointing a lot of the things that we've talked about. In this presentation, there's also a couple of blog posts regarding security in MongoDB. So now for questions. We have 5-10 minutes. I'll try to go through them. Any chance of data loss during switching from SL enabled to SSL disabled? No, either way, it's actually not possible to switch from SSL enabled to disabled without downtime. By definition, we don't want to offer the opportunity of going to a less secure system without making a sort of, we don't want to do that in an automated fashion. But no, neither of those, changing the SL configuration, there's no chance of data loss. So you stated that SL3 is disabled. What else can we use instead of SSL? So the next version is TLS. So TLS is simply, you could think about it as SL 4.0. So there's TLS 1.0, 1.1, and 1.2, and those are supported. And all of the MongoDB drivers and most of the applicable, I would say all SL libraries in the world currently support TLS. So that should be a non-issue. can you talk more about what is an encrypted storage engine? I could talk a lot about that. I'll suffice to say for now, we have in 3.0, we have enabled the pluggable storage engine interface, which means that it's possible to plug in different storage engines, and we are looking into giving the WireTiger storage engine encryption capabilities. More about that later when but that's sort of on the roadmap. What is the impact of auditing on MongoDB? Does it slow it down? Yes. Well, it depends. That's any extra activity you are doing would slow it down, and that's also why we offer the different filters to, let's say you just take the example of, let's say you audit every read and you need to write something. If you write something for every read you do, obviously it's going to slow things down. So we have a baseline, and we have some numbers that we've computed for certain types of workloads, and essentially it has to boil down to individual experiments locally to see what are, given your user configuration, given your auditing filters, what is an acceptable degree of sort of slower performance. What I would say the main thing we've thought about and tried to make sure is that non-audited operations are affected as little or no or none at all. So it's acceptable to have audited operations being affected, but we'd like the non-audited operations to not be affected. I think those were the questions that I feel had general applicability. There are a couple of questions that I'm not that I would like to talk about or feel free to email them if your question was not answered yet, and we can have a more sort of one-on-one dialogue around it. I thank you for your time and listening. My email address is andreas.nilsson@mongodb.com. Feel free to email me, especially about suggestions. If you find things that are unintuitive or not working the way you'd like to with the security system, I would love to hear about it, because we're trying to improve all the time. So once we finish this off, if you we'll be asking a few questions. If you would like to just hold on for a few seconds and give some feedback on the webinar, that would be awesome. So thank you for this time. Thank you for listening, and I hope to see you all at MongoDB World.